Hello everyone, and welcome to the second webinar of the Adaptation Design Tool mentored online course. My name is Sherry Wagner, and I'm the Reef Resilience Program Coordinator with the Nature Conservancy and the coordinator for this month-long training. And today I'd like to also introduce our mentors that are on the webinar, Jordan West, Britt Parker, David Gibbs, and Chris Berg. And this webinar is being recorded so that you can view it again later on if you have any, want to follow up on anything. So to get us started today, I wanted to ask you a few questions, launch a few polls. So the first question is, if you remember from the first assignment, we had a compendium to review. So our question for you is, did the compendium include adaptation ideas that you are not aware of? So you're familiar with most of the ideas. There were a lot of new ideas. Most was new or other. Just want to get a sense from you so we figure out where you are so far. Okay, so I'll share with you guys the results. It looks like everyone that took the poll said there were a few new ideas, so that's great. And the second poll, do you have a vulnerability assessment for your site? So this is so we can, that was also something to review from the first assignment there. So I have something similar. I have partial information, but not the type that was used in the example. I have no information or other.
Sherry, I'm not seeing the poll. Oh, there it is.
Sorry, guys. Yep, I just launched it. So the vulnerability assessment for your site. Here are the choices. Okay, I'll give you a second to vote. All right, so I'll share with the results with you guys. So it looks like it's split. There's some people have partial information, some have no information, or we got some others. So maybe they do not have one at all. Great, thank you for taking the polls and giving us a little more information. So today on the webinar, just a reminder, when we have our discussion and Q&A periods, for that time you can type your question into the question box and send it to me, and I'll take those questions there. Or you can also raise your hand so that we can call on you, and you do that by clicking on the hand icon on the toolbar. And we have plenty of time today for discussion, so please use that time as a chance to get your questions asked, and we can have hopefully some open and lively discussion today. And if you're having any technical difficulties, such as trouble hearing or seeing the slides, send a message and also in that chat box, and I'll try to help you resolve the issue. So today, basically, wanted to re-show the course schedule and talk about where we are in this month-long course. So we held the orientation webinar at the beginning of the month, and then you went through lessons 1 and 2, which introduced you to the principles of climate smart conservation and gave an overview of the Adaptation Design Tool. And then there was a reading assignment, which was to review the CCAP compendium, and also the summary vulnerability assessment for Guanica Bay in Puerto Rico, which showed information on vulnerability and resilience. That's a key input needed to use the Adaptation Design Tool. And got my guys going here, and now we're at webinar 2. Today, which was, you completed lesson 3, which was activity 1 of the Adaptation Design Tool, which applies climate smart design considerations to identify climate change impacts on the effectiveness of your management action, and to consider what changes should be made to those actions based on the impacts. And then for the assignment, you were asked to use the example for Guanica Bay coral reefs to fill in worksheets 1A and 1B, and this is what we'll discuss today on the webinar. And so that's where we are now, is on this webinar 2 today, where we'll be talking about that. So now I will actually switch it over to Jordan, and she's going to go into a little more detail. So let me change it over to you, Jordan.
Okay. How does that look?
Yeah, it just came up. Yep, looks great.
Excellent. Excellent. Thank you. And sound is okay?
Yes, good.
Good. Well, welcome everybody who's on the phone to our second webinar. Very excited to have you and to be able to discuss activity one of the tools. Just want to orient folks a little bit. We still have folks joining the course. So if there's anybody new who's just joining, welcome. There's still plenty of time to benefit from the activities. And I'll just give a little orientation to Lesson 3 and Activity 1. So in Lesson 3, you learned on the online module how Activity 1, so this is the flow chart for the tool, just Activity 1, which concentrates on helping you consider how climate change affects the stressors of concern that are relevant to your management action. And when we say stressors of concern, they can be stressors of concern because the management action is designed to specifically address a stressor, or it can be a stressor of concern because you're trying to do something with management that could be affected by or is in response to and needs to account for certain stressors. So there's two different ways stressors can be of concern. And if those stressors are changing due to climate change, we want to know that. So that's Worksheet 1A. Then from that flows implications for how effective your management action will be, given the changes in those stressors, but also given any direct effects that climate change may have. So in other words, an action could be impacted through changes in the stressor, or climate change could directly, physically, perhaps destroy or damage, especially physical structures that are part of management activities. So the homework assignment, which hopefully everybody was able to download from the course page, gave 3 different actions in a table in the Worksheet 1A and Worksheet 1B tables. You were asked to first review Action 1, which was a fully filled example, to get an idea of the kind of information that would go into the cells. We then provided a second action that was partially filled, and in some ways had some similarities and some differences to Action 1 to get warmed up on it. And then we had a third action that was completely blank. Actually, I want to go back and make one more comment about this. The tool can be used at different levels of depth. So what you're going to see in the example that we're going to show is probably a medium level of detail. It's not the coarsest level possible, and nor is it the most detailed level possible. It's sort of in between. And one of the hallmarks that we've found with using the tool is that even if you're missing really good vulnerability information or don't have as much familiarity as you would like to have, even if there's some uncertainties in the knowledge of the group of people using the tool, the point is to just start getting information down, just start getting the knowledge down in the worksheets. And even with the most expert groups, what we find is that as folks proceed through the activity, they often find themselves going back to add more information into earlier worksheets or into earlier columns, because as the thought process proceeds, more and more ideas kind of come to the surface. So it may be that maybe if you take a shot at one of your own actions, the answers are a bit shorter and maybe a little coarser than some of the examples that we're giving. And that's okay, because the point is to get to the beginning of a restatement of the action with the best available knowledge that you have right now. And it then also reveals where you probably need to go back and get better information. So before kind of opening it up to the broadest discussion, we thought it might be useful to have a featured participant. We're so happy to have Chris Berg with us of the Nature Conservancy. He's the Director for Conservation in South Florida, and he is on the steering committee and one of the main leaders of the Florida Reef Resilience Program. And among other things, they are revising their climate strategy, and one of the activities that they're particularly interested in, among others, is coral reef restoration. So Chris had an opportunity, we had an opportunity with Chris and the FRRP to talk about the tool at a recent meeting of the U.S. Coral Reef Task Force. And so Chris was able to kind of take a shot at trying this out for an action for this action 3 that we put in the homework, which is of particular interest to them. So we thought we could have Chris kind of go over the example that he worked up in collaboration with some of the other folks from the Florida Reef Resilience Program, and could see if other folks came up with similar ideas or different ideas. So Chris, if you'd like to take over, that would be great.
Okay, thank you, Jordan. Thank you all for joining us. Again, my name is Chris Berg. I've been working here in the Florida Keys and South Florida for about 20 years on coral reef conservation. Grew up here in the Florida Keys, and I've seen, unfortunately, a whole lot of coral reef degradation over those years. And I do attribute a lot of that to the effects of climate change, of course, working in concert with lots of other stressors. But I'm really interested in tackling these challenges, and I've been enjoying getting to understand the Adaptation Design Tool and the Adaptation Design Tool and how we might be able to put it to work here in Florida, both for the individual interests of the Nature Conservancy, but also most specifically for the Florida Reef Resilience Program, which is a multi-agency, multi-stakeholder working group of people interested in reef protection and sustainable uses. We've been working for, since 2005 on a whole suite of scientific and proposed regulatory approaches, really coming at the problems from all sorts of angles. And as Jordan said, we also have a very robust coral reef restoration effort going on, not only the Nature Conservancy, but lots of other partners of ours, private organizations, academic institutions, and public agencies. So the example that you have before you in Worksheet 1A is not focused on a site that I'm very familiar with, but it is focused on an adaptation strategy or a reef conservation strategy that I'm pretty familiar with. And we'll just start to walk through it. So again, you've got Worksheet 1A. The action here, number 3, is outplanting aquarium-grown corals on reefs surrounding the mouth of the bay to enhance coastal protection and reduce coastal erosion. The reef restoration work that my group and others are involved in here is not explicitly focused on dealing with erosion and that sort of a goal at this point, but it is something that we're beginning to explore. So it was really great to work through this. Looking now at column A3, the stressors of concern. The warming ocean temperature is certainly something we're experiencing and have expectation that's going to continue. Lower pH, more acidic water. Another stressor, terrestrial sediment and nutrients. The location of our example here, the Guanica, Puerto Rico watershed, has a lot more topography than I'm used to in South Florida, but runoff from the land is a challenge here as well as in Puerto Rico, even more so in Puerto Rico. Sea level rise, yet another stressor. Diseases, coral diseases and others. Acute impacts from storms, those are in addition to the impacts of sediment and nutrients that were covered earlier, such as direct breakage of the coral, scouring of the coral, and so on. We've just had a very firsthand experience with that here in Florida, and certainly in Puerto Rico and the Virgin Islands. Lots of impacts on our corals from these hurricanes. And then acute anthropogenic impacts such as vessel groundings, anchor damage, etc. So those were the stressors that we identified. And then the question addressed by column A4 is how is climate change affecting these stressors? Which direction are they heading? Which magnitude? Are they likely to become greater or lesser? What are the mechanisms? How is this likely to work? And the uncertainty, or how certain we are that this is likely to occur. We expect warmer waters to be on the increase. We've seen that on the increase. We expect it to continue. Not only higher temperatures each year, but longer duration of the high temperature times. And the magnitude of that is likely to be quite high, and there's low uncertainty. That's very clearly indicated by the trends that we've been experiencing and by the models that are suggesting more and warmer water in the future. So more intense storms may produce runoff carrying more sediment and nutrients. The percent increase in erosion and runoff may actually be quite a lot larger than the percent increase in precipitation. So this is not a one-to-one relationship. A little bit more precipitation can cause quite a bit more erosion and runoff. So again, high magnitude of the change, the effect, and low uncertainty. When runoff occurs, those stormwater plumes may extend farther into the ocean, impacting larger areas of coral reef, or areas of coral reef farther away from the river mouths or the discharge points. Again, high magnitude and low uncertainty. The next one, sediment and nutrient runoff may be exacerbated by drier, more erosion-prone soils. So as deeper droughts occur as a result of climate change, the soils may become more prone to runoff as a result of those droughts. Medium magnitude and a low uncertainty. Storms of sufficient intensity to release levels of sediment and nutrients and cause breakage and scouring may exceed reefs' tolerance and may occur more frequently. So larger, more powerful storms, making it harder for the reefs to cope with their impacts. Have a high magnitude and a medium uncertainty. Next bullet, increased disease virulence and weakened coral immune systems due to warmer water. There is clear evidence that this is the case. Warmer water tends to exacerbate diseases, tends to weaken the corals, make them more prone to get the diseases. The magnitude here is estimated to be medium with a medium uncertainty. Sea level rise may occur faster than reef accretion, leading to sinking reefs. We, here where I live in Florida, are not seeing a great deal of reef accretion, if any, at this point, and sea level is clearly occurring, so we worry about this quite a bit. Medium magnitude and a low uncertainty on this one. And finally, ocean acidification may decrease colony growth rates, reproduce their reproductive potential, and make it difficult for them to successfully recruit if corals cannot chemically queue to settlement sites or put energy into gamete production or calcify. Another one with high magnitude and a medium-high uncertainty. So there we've looked at how climate change would affect the stressors that are affecting the corals that we care about. And in column A5, we are looking at the timing. So temperature effects are already occurring. They're well documented, and they're likely to increase in magnitude through mid-century, if not beyond. Increasingly violent storms are already occurring. The science's ability to say, you know, this particular storm was caused by climate change is still not very clear, but we can say that because the oceans are warmer, the power of these storms is greater. And then storm intensity will likely to continue to increase over coming decades. There's nothing to indicate that the water will stop getting warmer, and storm intensity is tied to ocean heat content. Finally, acidification beyond coral's optimum range may have already occurred for some taxa, and it is expected to worsen. So many of these things are happening already. Looking at column A6, the implications for effectiveness metrics and how to measure them. So if back to column A2, if what we're trying to accomplish here is outplanting corals so that they can protect us from coastal erosion, we want to know a few things. Some of the effectiveness metrics are the survival and growth rates of the outplanted coral colonies, including their genetic diversity and how they are reproducing. Are they reproducing at all? If so, are they reproducing asexually through fragmentation and or sexually? And then, because our interest in planting them is not strictly a biological one or a ecological one in this case, but it has a utilitarian function of reducing erosion, we might want to look at wave heights. Did the planting of these corals reduce wave heights between the corals and the shore of concern? And then reduced erosion rates. Did the reduced wave heights translate into reduced erosion rates? Implications for effectiveness metrics. We may want to look, as a result of climate change and all of these stressors and climate impacts on them, we might want to look at survival rates of the corals that we have outplanted for a longer time than we otherwise might, for perhaps years and years, because these survival rates may decrease due to more episodic events like storms or coral bleaching events. Growth rates may change over time in a negative direction, and the time until sexual maturity and reproductive success may increase due to ocean acidification. Sea level may also offset whatever reduction in wave height and erosion rates that we get. So the concept here is that having more coral on the reef growing and creating roughness, creating friction, will actually slow down and reduce the size of the waves and thus reduce the amount of erosion. But sea level rise, if it is fast enough, can offset whatever increases in coral growth rate and increased roughness we get. Also, increased sedimentation may interact with wave heights and erosion rates. So this could go either way. So more sediment coming off the land and into the marine environment could conceivably shallow the water up, having an impact on wave heights and where the waves break and where they don't. It could also add sediment to the nearshore environment and create more sediment to be eroded. In essence, adding more sand or sediment to the beach, which would be a good thing. More sand creates more of a protected buffer on the beach. So it could go either way. And then also increased, next is the implications for how to measure the effectiveness metrics. So monitoring survival longer than you otherwise might because of these more intense and frequent episodic events might be necessary. We might want to monitor the rugosity or the roughness of the reef, which translates to its friction and wave attenuation properties. And we may want to monitor the actual wave heights and erosion rates to see if the desired effect is taking place. And the final column A7, some notes of interest came up along the way during these discussions, and I'll just recap them. And one question was, is there a certain level of rugosity about plants that is desirable? We don't have a good feeling for that. We know that the more rough the reef is, the more rugose it is, the better its wave attenuation properties should be. Another note from some work that's been taking place here in Florida and elsewhere is this relatively new technique of microfragmentation, creating many small coral colonies from one larger one in the laboratory setting here at Mote Marine Lab in the Keys as elsewhere, and then taking those many smaller microfragments and gluing them or fixing them down onto larger dead boulder coral colonies like Orbicella or others, in order to jumpstart recovery of that entire coral head. So having a network of many small pieces that are not touching but nearby one another accelerates their growth, and they grow together and resheet or reskin the larger dead coral colony more quickly. And the question here was, could that technique be employed? Another here is, since this action is so closely related to the nursery action, it will be important to adjust nursery rearing practices in response to outplanting results. So if you're growing species X in the onshore coral nursery and planting it out and finding that most of them perish or that they don't thrive, there's some probability that the problem is in the rearing phase in the onshore nursery, and trying to figure out if the corals need to be hardened, made more tough before they're put into the natural environment, or any other factors. If there's something that can be controlled in the culture phase prior to their outplanting, which can help. And then finally, effects of ocean acidification on these different coral life stages are relatively unknown. Obviously, there's a lot of work going on that front, but it's still in the early days. So I've been talking a lot. I think if it's okay with our moderators, I'd like to pause and see if anybody has anything they'd like to add or questions before we move on to worksheet, the next worksheet.
Okay, thanks, Chris. So yeah, right now, if you have a question on something that Chris has gone over so far, or want to discuss something at this point, you can raise your hand by clicking on the hand icon, or you can also type into the question box. And we'll have also some time later. Sorry, go ahead, Jordan.
Oh, I was just going to say, I'm also interested in knowing from folks, you know, whether they had similar ideas, whether they came up with something similar, or whether they had any additions, or whether in thinking about their own sites or their own examples, the answers would be quite different for that reason.
Okay. Yep, so not getting anything right now.
All right. Well, we'll go through the next worksheet. I'll do the same thing, that is walk through it and pause at the end, and look forward to questions and additions that we missed, comments as well. So worksheet 1B, in previous worksheet, we outlined a lot of the factors of concern, and in worksheet 1B, we begin to transform that information into a more climate smart action. So our existing starting point, our management action, was outplanting aquarium grown corals on reefs surrounding the bay to enhance coastal protection and reduce coastline erosion. We're going to work our way through the columns over to the bright green one, which is a modified version, which should be more climate smart. So looking at column B3, changes in effectiveness of management action due to climate impacts on the target stressor. So the first bullet here, areas that are suitable for outplanting may change due to extended sediment plumes from rivers. So if climate change leads to more sediment reaching farther out into the ocean, further out to where it interacts with more areas of coral reef, that can affect where we may succeed at outplanting, or if nothing else, make it more difficult for outplants to survive or thrive in the areas affected by that sediment. The next one, decreased growth and reproduction rates of the outplanted corals due to ocean acidification. So what we plant out there may not perform as we would have expected 5 years ago, 10 or 20 years ago, as a result of more acidic water conditions. These stressor effects listed above may reduce the genetic diversity of outplanted colonies below the intended level. So whereas we may pay careful attention to growing a diverse set of genetic individuals in our culture phase, on the onshore aquarium-based grow-out phase, if certain genotypes fail to thrive or perish completely once outplanted, we may not have the sort of diversity that we hope for. And finally, increased death of outplanted colonies from bleaching, from diseases, from storms, from the interactions of all these three things. It's likely to be a tougher environment that these corals are going to need to persist in the future. Column B4, changes in effectiveness of management action due to climate impacts on the management action. So if our outplanting, our taking corals from the shore-based facility out to the restoration site or the planting site is dependent upon good boating conditions and good diving conditions, we may see fewer of the good days available if the weather is impacted by more storms, stronger storms due to climate change. Methods and materials for attaching the corals to the substrate may not withstand stronger storms, so the sorts of glues and cements and mechanical fasteners that are used today in the arrangements that they're used today may not work as well if we face stronger storms. The preferred outplanting season may shift. We tend to do our outplantings here in Florida in the cooler winter months when corals are generally less stressed, but the duration of the hot spell, the hot time of each year may increase, leading to a smaller window within which we can affect outplanting. Also, an increased chance of damage to the aquarium grow-out facilities, the nurseries, due to storms. So we have recent experience with many different in-water nurseries in our case, but also some land-based nurseries in Florida. Some were affected very severely by the storm and others not, depending upon their location and relative to the eye of the storm. But the more storms that we have, the greater the chance of a negative interaction. And finally, sea level rise may offset any wave height or erosion reduction created by coral growth or ergosity. So if the corals are growing at a pace of, let's say, 10 centimeters a year for some of the fast-growing branching species, but the sea level is rapidly accelerating as well, there's a dynamic there where we may not get as much benefit as we would hope if the sea rises more quickly. Moving into column B5, the time frame or constraint for using the action and implementation. How urgent is this, or can it be put off? So the thought here was that the sooner this is initiated, the better. The sooner that the corals can be established and begin to serve that wave attenuation function, the better. And also, outplanting may have to be sustained long term. So instead of anticipating one big outplanting one year, it may be necessary to do that and then follow up on an annual or whatever the frequency is, and a more frequent basis, in order to fill in gaps, to replace corals that were planted but died or didn't thrive as intended. Moving on to column B6, what changes are needed to adapt the action, whether it's the place, the timing, the design. The first item here is focusing on outplanting coral strains with a variety of types of tolerance to climate change effects, including being bred to tolerate multiple stressors. So there are certainly some genotypes of corals, of their symbionts, etc., that are more tolerant of heat stress, for example. And beginning to factor that into these kinds of projects is very much on people's minds. Stress hardening the corals is a related idea, where the corals are exposed to high temperatures or a long duration of high temperature in the laboratory or in the grow out facility prior to their introduction into the wild, so that they're tough when they are placed into the wild. Identifying or developing stronger attachment methods, for example, using more cement or glue or more mechanical fasteners like nails may need to be used to ensure that these, or increase the likelihood that these outplanted colonies will survive a storm. The timing of outplanting to avoid periods of runoff or other land-based pollution or heat stress for that matter may need to be altered. And factoring changes in sediment plume locations and directions into outplanting. So if you know that sediment plumes are likely to continue to reach the areas that they've been reaching and even perhaps expand their impact area, you may want to choose areas that will not be affected or not as affected for your outplanting. You might want to extend the monitoring longer than you otherwise might have to include observation of how the outplants handle extreme stress events like bleaching events, like hurricanes and so on. And also keeping tabs on how they reproduce over time. And finally, it may be essential to establish more than one coral growing facility to reduce the risk of losing all of your stock from one storm impact or other catastrophic event. So taking all of that on board and using it to modify the original idea, which again is found in column B2, we now have in B7 a more climate smart version of the same action. So using species that effectively protect the coastline, outplant colonies that are heat, disease, sediment, and or low pH tolerant, avoid outplanting during high sediment or precipitation periods to reduce initial stressor exposure to outplants. Colonies should be affixed to reefs using stronger attachment methods due to larger storms. Site selection should be adjusted for shifting plumes of land-based pollutants from the bay. Because survival through extreme events is an important part of the nursery program, colonies should be monitored through extreme events such as high temperatures and large storms. And monitoring periods for outplants should be extended to determine if they are surviving through these stressful events. And more than one growth facility should be sited and established to spread the risk of total loss. So that is our more climate smart action item. And I'll briefly review some of the additional notes that came up here in discussion. So reefs to the west of Guanica Bay receive more sedimentation than those to the east. However, a reef resilience assessment shows that there are potentially some suitable sites to the east. So those could be, if you need to do this treatment on the east side of the bay, it may make sense to focus on the more resilient areas or the ones that have been identified by this assessment. There is a need to focus on other activities that are important for improving the outplanting environment. So it makes little sense to plant corals into an area where corals have been decimated, excuse me, if you aren't also addressing the root causes of that decimation, whether it's water quality or destructive practices of some kind, what have you. And then finally, there was a question about how we could attach multiple colonies to the bottom simultaneously, essentially increasing the pace at which outplanting could be conducted. So that's the run through, and we welcome your comments. If you, in your review of these worksheets, either 1A or 1B, identified additional items that we didn't include, we'd love to hear about them. If you have questions about anything that we proposed here, welcome to ask them. And if you have a site with a different set of challenges that is similar, or you'd like to talk about, or bounce off of this group, we welcome that as well.
So, Chris, while we're waiting for people to type or raise their hand, I had actually a quick question myself. Even though I've read this several times, it suddenly occurred to me when you were talking about plumes extending further out and, you know, how you might want to avoid those areas. And then I was thinking about, well, and we probably also would want, if the purpose is coastal protection, to locate the parts of the coast that seem to be having the biggest storm impact. So do you know anything about information on, you know, do storms typically behave the same way, or are they always different in terms of the way currents are driven up against the coast and the way the topography of the coast sort of interacts with the prevailing wind and currents? And is it possible to identify where you would get the biggest benefit from, if you could establish if you can only outplant certain places, maybe that would be another determinant of where you'd want to focus? Or is that information even known?
Well, I think there are two ways to answer that, and I'm not a coastal geomorphologist or anything like it, but I think the landscape and seascape, you know, give indications to us about what the local current and sedimentation and storm conditions have, how they have shaped the local conditions, and having a sense of how, with perhaps deeper water due to sea level rise or stronger storms, one can guess, I think, or surmise what those changes might be like. That would be as much as I could do, but there are specialists in geomorphology, coastal geomorphology, etc., that can, with pretty good accuracy, model these things and do all sorts of fancy scientific assessments of what to expect.
Yeah, cool.
Okay.
So that's something I would probably put down in the notes. Oh, go ahead, Sherry.
Yeah, no, that's okay. We did have someone with their hand up, so I was just going to call on them when we are ready to move on.
Excellent.
Okay, so we have a question. Laura has her hand up, so Laura, I'm just going to unmute you now. So you're unmuted. You want to ask your question?
Yeah, are you hearing me?
Yes, we can hear you.
Okay, thank you. Yeah, I would like to know how feasible is to use some structures to, like in the case where a storm is very strong and destroy the ecosystem, the structure of the ecosystem. How feasible is to use fake structures made, for example, with concrete, but the most similar structures, more similar structures as a real coral reef, and then as a base to transplant the new corals, maybe to like an additional strategy of the one you have here, to use using more stronger materials. Like if you use these things, it is possible to help in those cases?
Great question, and I think there are many examples around our coasts in coral reef environments and others where artificial breakwaters are employed for this purpose. The example that we provided was a very, let's say, very naturalistic approach for improving wave attenuation and reducing erosion. But there are cases where that is not physically sufficient or not practical for one reason or another. and there are many places where breakwaters of one configuration or another have been established. And then more recently, there's, as you indicated, sort of hybrids between the two, where artificial materials, whether it's concrete or rocks, boulders, what have you, or combinations of rock and steel, are the foundation upon which natural native corals or other organisms are transplanted, and they then contribute. So the structure that's placed contributes to wave attenuation, and the additional corals on top of it add to the roughness and also make it more adaptable, because the concrete and steel and boulders will not themselves grow and keep up with environmental change, but the organisms that are growing on them, whether they grow of their own or whether they're planted on there to grow, can, under the right conditions, grow and keep up with sea level rise, with other forces of erosion, and so on.
Thank you.
Okay, so I'm not seeing any other questions right now. Do we have any from our panelists or Jordan?
Well, this is Jordan. My fellow panelists can speak up, but what I was thinking was that thank you, Chris, for the excellent kind of overview of, and I want to emphasize to folks on the phone that, you know, this is a version that has been gone over several times by various different people. And yet, every time I hear it or read it, I almost always come up with a new question. So that's kind of what it's all about. And thank you, Laura, for your question. But I thought maybe, if Chris, you don't mind, maybe open it up to some broader questions, since we have kind of 10 minutes left. I just want to throw several things out, and anybody can address any of these questions. I was wondering how folks did with Action 2, which was the partially filled one, and I actually have the Word document here, and if anybody is interested, they can weigh in and type a message, and we can sort of show our answer keys for that action. I'm also wondering if anyone on the phone tried out their own action, which was the extra credit, and might as well just throw everything out there. We were also just wondering if, and would love, even after the call, feedback on the forum on any of these things, how the experience was working through the lesson itself in the interactive module, and how the experience was using the worksheets. So if people have any reflections on any of those things, or would like to talk a little bit about example number 2, those are some options that people can weigh in on right now.
Okay, great. Okay, so you can, again, raise your hand and we can call on you. Or if you'd like to just type something into the question box, go ahead and do that. Okay, it's not looking like anyone has any responses right now. You're going to your worksheet, yeah. Okay.
Oh, I'm sorry. So I was on mute.
Oh, sorry, Jordan. Go ahead.
I was saying something so wise. I was on mute. I thought, yeah, since nobody has any particular questions, I thought we'd just show this briefly, especially if any folks go back to the exercise or if folks listen to the recording later and are going to do the homework. It might be worth just showing this quickly. So this planting cover crops example has some similarities in that it is a method for controlling terrestrial sediment and nutrients. So it has some similarities to the riparian example that was fully filled. So one of the first things is, this column that's outlined in blue was left blank. And actually, these answers are very similar to action number 1. And we didn't really mean to make it seem like a trick question or anything, that it should be different when it's the same, but I think it really illustrates what one of the recommendations in the tool is, that if you have a series of actions that address or have similar stressors of concern, it is often good to group them because you can save a lot of time where there are certain columns having to do with the stressor and climate effects on those stressors that are going to be somewhat similar. So in fact, there wasn't a big difference there. And in this, in this one, we have similar effects to action 1 in terms of intense storms producing runoff and stormwater plumes, all similar to Chris's example, extending further, sediment being more intense, extending further, same exacerbation with erosion-prone soils, more intense storms releasing higher loads, and more intermittent sediment and nutrient delivery, with some questions about, what do we know about how those patterns of precipitation are going to change and how the spatial and temporal kind of intermittent patterns might change. The rest of the columns you guys have the information on, so I'm not going to go into a lot of detail, but we do expect these changes in patterns, and the notes have some interesting comments like, how much are 2 versus 5 versus 10 or 25-year storms going to change? And it's really all about how are the patterns and intensities of both temporal and spatial patterns and intensities of sediment delivery going to change. And then it gets more interesting in this one, of course, because cover crops are different than riparian systems. So, but in some ways similar. There's this concern about whether the cover crops will be able to retain sediments and nutrients when you have more intense events, whether they'll basically be overwhelmed and unable to basically meet the objective of retaining sediment sufficiently. And as the soil becomes drier, it becomes more erosion prone. And then, so that's the effectiveness of the management action, changes the effectiveness due to the stressor changing. And then what are the direct physical effects that climate change could have? Cover crops could actually be uprooted and just physically completely washed out from stronger storms, especially in the steeper sloped areas. Or they could be, the species of cover crops could be insufficiently tolerant of heat and drought conditions, so they could die. And large storms, this third one, between the harvest of the crop and getting the cover crop planted could cause a lot of ponding and make it very difficult to establish the cover crop. So this is a good example of the reason these two columns are here is not every action is necessarily got physical direct effects of climate change, but a lot of them do. And it's not really important which column you put it in, but it's important to think about whether there's a stressor-mediated reason that the action might be affected versus just a direct climate impact on the action. So the implications of all of this, really quick, are that cover crops should be selected for drought and high flow resistance wherever possible. We have you could ask some questions about what are the different types of cover crops that are available and what species might be more or less resistant You should probably do some kind of analysis and prioritize fields that are near irrigation channels and on steeper slopes, or any other information that gives you an idea of where erosion is the biggest problem. That might be if you can only do a certain amount of cover crop planting where you would want to focus the most. And replanting as soon as possible after the previous crop so that you have you don't have the fields uncovered. So your final thing is annually planting a mixture of cover crops that are drought and flood resistant and timing them so that they will protect the soils from rain during the strongest storms. Preferentially planting your irrigation channels and on more erosion prone soils, and monitor and be prepared to replant in case of damage from extreme events. So you may need to replant more often, more than once a year. And it's possible you'd even plant different cover crops in different years depending on the weather prediction for what kind of weather is expected right after the crops are harvested. So your buffers may need to be checked and replanted more frequently because of increased storm intensity or for other reasons. Sherry, I don't know if any other questions have come up.
Yes, we do. There's a comment and a question. So first, the comment was, I thought the example was straightforward and the worksheets are useful, and hearing Chris's information was reinforcing. So that's great. Thank you for that. And one of the questions was, has this process using the worksheets ever resulted in the complete abandonment of an existing management action?
That is a really good question. I guess I don't know, because we've never quite yet. I mean, we're still in this process where we've been interacting with folks who are trying out the tool, and I guess we actually haven't been able to circle back yet and get kind of final implications in terms of then taking these ideas and how does it then affect your evaluation and selection. From the perspective of when you do structured decision making, you always want to try not to immediately throw out options, and you always want to try to take them, and evaluate them. But there are times when it's really, really clear that, and that is the goal, is that you want to get an idea of, this action really has some potential to be modified and still work. And you get an idea that, this action, there's a lot of problems here, and it might not be possible for it to work at all. So that's a very astute question. Those are the insights that you start to get. And what we're trying to do now is we're in the midst of some collaborations where that will be the next stage, is to talk about, okay, now that you've got these climate smart versions, how do you use that information in evaluation and selection processes to evaluate and select your combination of things you're going to want to focus on, in part because certain actions you now are much more clear on might be more problematic than others to use. So I'm hoping we'll have an example of that, but we did have a short example from our West Maui collaborators that wasn't due to the tool. It was something that had already come up even when we were looking to select actions with them for them to run through the tool, where they had something called baffle boxes that they would use in their watershed to, there are these boxes that filter out leaf matter and, some sediments. And when they spoke with their local experts on how precipitation patterns were changing and likely to result in more of these, what we call flashy events that are very intense, the experts immediately said, well, let's just forget baffle boxes right now. They're really not designed to handle high flows. So that is an example of an action that, in that case, it was so obvious it didn't even need to be run through the tool first. But that is one example. And so this question of when do you go ahead and throw something out, and when do you do more research to see if it's still a valid option, is one of the questions that we have about how you move forward with your decisions.
Great, thanks, Jordan. I'm going to go ahead. I have one more slide to wrap up, unless you have something else you wanted to add, Jordan?
Nope, thank you.
Okay. Okay, well, thanks everyone for joining us today. I'm just going to show you, got one last slide here. So basically we were at this point where we had the webinar today, and then now we're going to move on to the next section of the course. So between November 7th and November 17th, you should complete lesson 4, which will demonstrate activity 2 of the Adaptation Design Tool. And this will will show you how to identify gaps in your existing management plan and helps you brainstorm new actions to fill those gaps. And we'll conclude with next steps on how the tool results can be used to inform other steps of the climate smart conservation cycle. And then there's also an assignment which you can work through. It'll be another worksheet to fill in. And during this section, mentors will also be available to answer questions and respond to your comments on the Reef Resilience Network forum, the online discussion board, up until November 16th. And you'll find all the instructions there on our course page. And then we'll have a final webinar where we're going to go over the assignment like we did today in another format. We have another guest who will be joining us for that. And then we'll be concluding the course. And you get prizes. You hopefully will have the prize of having learned a lot and been able to give us feedback to help improve the course in the future. So thanks again for joining us, and have a great rest of your day.
Thanks, everybody.
Thank you.